Welcome. We want to see how to determine the nature of turning point. Remember, stationary points are also called the turning points. So if this is the function of that curve, 4x cubed minus x raised to 4 plus 1, as stationary points, the gradient function is normally is equals to 0. So you differentiate this original function once. To differentiate, remember, we normally multiply by the power, then less the power by 1. That gives you 12x squared. Then also this one becomes 4x cubed. Then this one, because x raised to 0, it becomes 0, so it disappears. So you end up with 12x squared minus 4x cubed is equals to 0. So the gradient function is equals to 0. Therefore, factorizing this one, 4x can divide both of them, so it becomes 4x in brackets, x minus 3, which is equals to 0. That implies that this 4x is equals to 0, so that x1 is 0, or 3 minus x is equals to 0, so that 3 minus x equals to 0, implying that x2 is 0. We have already found the value of x's at the stationary points. What about the value of y's? So x1 will go to y1, so you replace the value of x in the original function of y to get the value of y1, so that replacing here 0 as the value of x1, you get that 4 in bracket 0 cubed minus 0 raised to 4 plus 1 is equals to 1. Therefore, y1 is 1, implying that that stationary point is 0, positive 1. The value of y2 also goes with the value of x2 that you have found it to be. x2 is equals to 3. So replacing also gives us 4 in bracket 3 cubed minus 3 raised to 4 plus 1, which gives you 28. Therefore, that stationary point when x is 3, y is 28. So having now the values of the turning points as coordinates, how do you know that it is either a maximum point, a minimum point, or a point of inflection? So we move on and find the second derivative. Remember, this one is our first derivative. So you again differentiate this one. When you're differentiating this one becomes 24x minus 24 minus 12x minus 12x squared. This one is supposed to be 12x squared because we're talking about 3 times negative 4. This 12x squared. Therefore, it can be written as 24x minus 12x squared as a second derivative. So replacing here the value of x from the turning point gives you 24 in bracket 0, so minus, also this one is supposed to be 12 in bracket 0 squared, but the end thing is also it gives you 0. Remember, 0 is a point of inflection because it can either be positive or negative 0. So you say that when you have a 0 as value from the second derivative, it implies a point of inflection. Continuing with the x2, replacing also the value of x2. So the value of x2 here, x was 3. So therefore it becomes 24 in bracket 3 minus 12 in bracket 3 squared. That gives you negative 36. But we are more concerned with the sign. The sign is negative. So because the sign is negative, it implies a maximum point. Therefore, in general, to know the nature of the starting point, you first find the second derivative of that function. Then, replacing the values of x so that if it gives you a value of 0, that implies a point of inflection. Then if it gives you a negative value, it implies a maximum point. Then if it gives you a positive value, then it implies a minimum point. If you have any question, again, after subscribing, kindly just drop your question.